They drew it for us. They told us exactly what it is, but they didn't label them. So let's label them first. So we have R is the shaded area. Okay. Here is the shaded area. They said y, so the graphs are the x-axis. Okay, so the x-axis is y equals 0. And then two graphs. One is y equals the natural log of x, and the other is y equals 5 minus x. One of those is a curve, one of those is a line. The natural logs are all curves. So the curve is going to be the natural log. And then the segment, the little line segment there, is the line, is linear. Okay. Find R. So that's area. So that's not this chapter. That's not, sorry, it's this chapter, but it's not this section, right? So if I'm trying to find area, what were the procedures, what were the directions for finding area? If I'm trying to find just the area of R, what did I do? How is that different than volume? So it's an integral, right? It's still an integral. Just like volume, it's an integral. But there was no axis of revolution. There was no cross-section, right? There was none of that. So if I'm trying to find area of that, what would I do? That's in other words what I'm asking. Because we've done this, you guys, we did notes on this. You guys had the practice assignment on this. This was practice 14. This is the one we did. It's been a while because we did it. I think we did this the last one we did before break. So if I'm trying to find area here, what do we do? Just area. What was that procedure? What was that formula? What was that method? What was that anything?
Yeah, the integrals from of the 1 to the intersection plus the part.
Hey.
Can I just sit back here?
Yeah, go for it. Yeah. Keep going. Keep going, Damien.
So it's you add two integrals together. Like first it's 1 to the intersection, then from the intersection to the end.
So we're going to divide up the orange into two. One's too smaller, right? Great. Why are we doing that? You're absolutely right. That's what we're going to need to do. We're going to need to break this up into two smaller pieces. Explain why.
Because those are two different functions, so you can't put them under the same integral.
So yeah, so when we did area, right, it was top function minus bottom function. Okay? And if you look, let me see, let me color code so we can get a better, we got that. Let me use a different color. No, I want to use that color, blue. And we got this one, right? And then the bottom is always going to be the y-axis. Okay. So we always go top minus bottom. But the problem is the bottom's always going to be the red, but sometimes the top's going to be the green, sometimes the top's going to be the blue. So we have to find two different areas. Okay? So what we're going to do is we're going to set up two areas. So R1 is this area right here, to the left of the dashed line right there. Okay? So we're going to set up our integral. Okay, so the integral and top function minus bottom function. Okay? So natural log of x minus y equals 0. dx, because it's top minus bottom. And then the bounds. Well, the bounds, it looks like it starts at x equals 1. and then it stops at this dot here. So we got to figure out where x equals there. So where do the green and the blue intersect? So that one you have to use your calculator. Where are natural log of x and 5 minus x going to intersect? What x value? Say it again?
3.693.
Yeah, 3.693. That's what I got, yeah. That's at x equals 3.693. Okay. Okay, and then you integral. Okay, so figure out what that's approximately. Top minus bottom dx. Okay. So hopefully you got 2.132. Okay. 2.132. Okay. That is R1. R2 has a new top, 5 minus x. Same bottom, 0. The bounds go from the dashed line all the way to the end dot. So from the dashed line here to this end dot. So we know where x equals on the dashed line because we just did that one. 3.693. And then where is this end dot when x equals 5? Yeah. Yeah, the easy way to do it is just, if I plug in 5 to the blue, it's 0. That's the 0. So that means x equals 5. X has to be 5. Good. And then find that approximation. So when you add them both together, R1 plus R2, you get 2.986. Good? Okay. That works. You got it. There's another way to do this. Now, you don't have to do it two ways, but I just want to show, since these are your notes, I want to show you a different way to do it. So is there a way I could have done it with respect to y, so dy? So instead of dx, dy. Yeah, right? But instead of top minus bottom, you would go left minus right. And it's always, so this way, if you do a dy, you don't ever have to switch. It's just all, the right is always the blue, the left is always the green. You don't have to worry about the bottom. Okay? So you could do it that way too. Okay? If you were to do it that way, it would be, let me just show you, it would be 5 plus y minus e to the y dy. And then the bounds would be y values, so it would be the bottom is 0, the top is 1.307. And you would get the same thing. So you don't have to do both, but I'm just showing you that if you had this question on a test, I had most of my students, when they did this question, they did it R1 and R2. That's how they did it, and they got the answer. I had like one or two that saw it the other way, so they did it like down there with respect to y, and they got it right too. Okay. Yeah, yeah. So this guy you have to solve for x, right? So you subtract 5, divide by -1. That's how you get this guy. And then this guy you solve for y. The only way to solve for y is by doing e, yeah, because it would be y equals log of e. So then you would go e to the x power equals x. Okay. All right. Okay, so the last two are volume, but they don't need you to solve it. They just want you to set it up. What would it look like? So using the same region, using the exact same region. Okay? So sometimes it helps to draw like a little sketch.
Okay, it's square.
So it's the same area.
So x squared is the formula, all positive.
There we go. Okay. Oops, okay. So R, still the same R. So it's not R squared and R, it's just R. So it's all one. I can't really erase it because it's a picture, but it's all one. Let's see. Let me highlight it again. So it's all one now. Okay, so now we got to find volume. It says cross section. So that's what we did this section. It's not what we did last section with revolving. It's cross sections. It's a square. It's perpendicular to the x-axis. So if it's perpendicular to the x-axis, what does that tell us?
dx.
Dx. And then it's a square, right? So yeah, area is just x squared. X, so area equals x squared. So that means each, try to pick a different color. So that means each square would go from this dot down to this dot here, all the way across. Okay? So let's set up our volume. So if we're going to find that, we're going to find this guy here. That's one of the sides, right? So I need side squared. So it's going to be top minus bottom. Top minus bottom. So natural log of x minus 0. Squared. Dx. What are the bounds going to be? Because it's an x, because it's dx. So what would the bounds be?
It's our 1 to
1.
6, 9, 2.
Yeah, so it's not going to be 1 to 5 because you notice that the green, at that dot right there, the green and the blue switch. So it's going to be 1 to 3.693. And then we need to have another section because it's going to go from blue to the red. So at this same spot, we have to switch. Okay, so the volume, so we have, what is that, 3.693 to 5, right? Top minus bottom squared. So 5 minus x minus 0 squared dx. You don't have to throw it in your calculator. That's all they wanted to see. All they wanted to see was the setup. So when I gave this question when I gave it, it was a non-calculator question because you didn't need a calculator to calculate that. Okay? So obviously for your guys', I'd probably have you guys calculate it. If it was a test for you guys, because it's all calculator, I'd have you guys calculate it. Okay? That's the only difference. All right. Okay, so the last one. The last one. So I'm going to draw a little sketch again.
Oh yeah, from 1 to E, no, 1 to T. No, well, 1 to 8.
Let's see, 1,
Point to intersection.
2, 3, 4, 5.
B to 5. 5 x, yeah. Just the sum of the variable. Yeah, we just say instead of find, we find form, find expression to find area. I'm assuming.
Okay. Here's the shaded part. It's the same graph, I just drew it by hand instead, so I could draw more on it. So there's our one is like here. 1, 2, 3, 4, and 5. Okay. So this is y equals natural log of x. This is y equals 5 minus x. And then this is y equals 0. Okay. Okay, so region R is the base of a solid. For the solid, each cross section is a semicircle, and it's perpendicular to the y-axis. dy. dy, okay? So it's a semicircle. So it's going to extend from over here all the way to over here. Area of a semicircle is pi times radius squared divided by 2, or 1/2. Okay. Right. Let's see. So let's figure it out. So dy, right? So it's dy. So it's going to be right green dot to left green dot. So it's going to be 5 minus x minus the natural log. Okay. So volume equals, so that's going to be, yep. So we need a 1/2. I need a pi, and I need a radius. So remember, radius, this is not the radius. From green dot to green dot is not the radius, that's the diameter. Radius is 1/2 of the diameter. Or diameter equals 2 of those guys, right? So it's going to be 1/2 times the diameter. Okay, so 5 minus x minus natural log. Now I haven't written those down. Why not? Because it's not in terms of y. It's not in terms of y. So I got to make these both in terms of y. Okay, so I'm running out of room here, so I'll just do it on the board over here. So y equals 5 minus x, solve for y. Minus 5 from both sides. Divide by -1. You get x equals 5 plus y. Or wait. Minus y, sorry. Positive 5, negative y. Or negative y plus 5. Okay. The other one, well, any natural log is a log with a base of e. Exponent, answer, equals power, or x. Okay. So This guy is actually e to the y, and this guy is actually 5, or no, 5 minus y. So we go 5 minus y minus, what is that, e to the y? dy? N squared, yeah.
Shouldn't that 1/2 still be in there too? 'Cause it's also,
It's also squared. It's also squared, right?
uh-huh.
So yes. Yep, let me clean this up a little bit. Y. There we go. There we go. Okay. But if I turn that answer in, I would get full credit. Why not? If I finished, if I like, okay, I'm
Oh, no
done.
bounds.
Yeah, there's no bounds yet. I have to finish the bounds. If you want full credit, you got to finish every part of it. So the bounds are y. So 0 to the dot, right? So 0 to the y value, which was 1.307. Yep, that's right. Okay. All right. So, let me stop recording.